Hello, welcome to another case walkthrough. Today I'm going through a case called Reunion or Reunion, a volcano island, an actual island in somewhere near Madagascar, I believe. I should know this, I actually knew someone who lived there, but anyway, that's beside the point. So this is from 2024 MEWC, I believe it was the last 16. I've had a quick look, I can't quite find what the live scores were, but I probably haven't looked very hard, so can't really compare with what was done by the pros on the day. This is a useful practice for me because coming up this weekend, or not coming up this weekend, coming up soon is the final round of the UK qualifiers, and we've been told that it's definitely going to have some map work, so always good to do some practice. So I've done a little bit of prep work beforehand just so this is nice and efficient. I'm also going to show a Lambda I've been working on that helps with this sort of map case, which funnily enough I was working on before this, and then I saw this case or tried this case and it came in handy. So yeah, that's a minute already gone, so let's get going. So in terms of setup, assuming you've seen this, we've got a map. We've actually got two maps. We've got one map of the island which has arrows representing kind of downward direction of how stuff would flow from the mountains or volcanoes down into the sea, and then we have the same map, and this time they've given us the topography, which was helpful because I imagine the original setup of the case just had this, and you were told to kind of create a version of this to find the topography, but maybe they realized that made it just a little bit too slow. So that's very helpful that they give us that. And we've got rivers where on some levels water doesn't flow, and then the sea as well. So yeah, let's get into it. I'm going to start at the beginning, level 1, and we'll do our work as we go. So watch direction arrows associated with the listed cell. So I'm going to go to the map. I'm going to go to the end of the map and then select the whole of the map and name that as MP A for MP arrows or map arrows, and then I'll do the same for the topography map as well. Again, just go to the end, control end, and then using my arrows to call this map T or MPT for topography. Okay, for some reason my other document, which is, well, I've got my answers open, it's playing around while I do that, so it's putting me off on my second screen. Okay, right, so I'm going to import my lambdas, and I'm going to say, let's start off with an address lookup. We're looking up the arrow map, and we're looking at these cells, and this lambda does take import an array input, so that works. So we find our arrows. Level 2, you're giving one cell where the magma pops. What is the next cell where the lava would flow to? So we'll start by finding the arrow by doing the exact same thing as before. So MPA, looking at this, and I'm going to do this one cell at a time because my next lambda doesn't actually take arrays. And so what I'm going to do is I'm going to wrap that in. So I've got an arrow now, so I now want to know where I'm moving on map. And my starting point is the cell which we're doing, and we've identified the arrow, and that should do something, but it's not. So move on map takes the starting point is the cell, so this is the wrong way around, and then the arrow. So I put those arguments the wrong way around, which is why we got that incorrect, and we fill those down and we get the rest of those. Right, level 3, the magma quantity will now take into account for level 3 only. We'll have a constant magma of 15. This means that magma travels 15 cells and fills them. For this level, you can ignore topography. This means the magma will start traveling along the rivers, still travel along the rivers. You're given one popping sound. This is where I'm going to use my lambda, which I'll get it working on here, and then I'll show you how it works in another document. So I'm going to say equals move through map of arrows, which is not the most succinct name, but we're going to start on this cell. We're going to through the map of arrows, and our custom number of steps, we're going to move 15 steps, and it's going to show us all 15 steps. So we're going to combine that with a take. I'm going to take the last row, and we get BU83. If I fill that down, we get all our answers. I'm just going to quickly switch to another document to show you how this works. So I've got a kind of map of arrows which I literally copied from this case, and I've got a starting cell which I'm going to put here, which is M13, and then this is my move through map of arrows. So what it does is it basically cycles through a sequence of numbers, and I'll talk about sequence, and performs the move on map lambda, so says where's the next one, and then just keeps doing that through. And I've got some conditional formatting that shows you the cells it's highlighting, and then I can work out where it's ending by taking the last one of that. So for example, if I change this to let's go somewhere else, so G6, then we see our movement. If I go back to M13, I've also set it up so this one comes out of the map, but if I change this outward arrow here to an upward arrow, we then see it actually forms a loop. And I've also got it so it then basically stops as soon as it starts repeating itself, which there might be a situation where that's not helpful, but who knows. I've also set it so I've got a custom input, because initially I said, because I'm cycling through a sequence, because it's not technically recursive, I haven't got a stop condition in there. Theoretically, you could have a cycle that goes all the way across, all the way down, and you would actually have to go through the total number of cells, so kind of 20 by 20 in this case, which makes it 400, which becomes very slow. So I've defaulted to saying, well, do it, add the number of rows and columns. So in this case, it would be 20 plus 20 and do it 40 times. And if I found that that meant I hit a limit, I could say, right, actually, I want you to cycle through 60 times. And if there were 60, it would then go through all 60. It also allows me, as we just did in the case, to say, actually, I only want to do 15 steps because that's as far as I want to go. So that's what I've done there. And I've seen 3 cases now where this sort of arrow map comes up. So it definitely seems worth having a Lambda for it. Right, level 4, you are now given one popping cell and magma quantity. Actually got a data table here so we can do this. What is the cell where the lava would stop? Please remember that if lava reaches the water, the flow is over. You have to answer the first cell with water, if any. Remember that both sea and river are water cells. So we are going to see, well, how many moves might we potentially take? I'm just going to check my working. So we're going to use that same lambda we've just talked about. So we're going to move through a map of arrows, starting at this cell, going through the map of arrows. I'm not going to put custom number of steps, I just want to know them all. So we get all of those moves, and we need to know what terrain we've hit. So now we're going to use address lookup on the map of terrain on that string. And we need to know that if that equals river or equals, so R or S, then we stop. So we're going to say, let's do the sum minus of that equals R plus, have I closed the bracket there? Nope. Plus the minus of that equals S. So that will give us all the cells where we have water. And so we're then going to say X lookup 1 in this range. So find the first time we have to stop and then return from this range. And that's going to give us some answers. I can't remember whether this is going to give us some errors where we don't reach when we don't reach water. And this is a little bit slow because it's having to go through that move through map, but let me double check those. Okay, I think we're okay. Maybe it's a later question. No, that is giving me an error. So just give me a second to check. Of course, what I didn't do was I didn't say I only want to move a certain number of times. So I'm going to say take from that. We want the top, in this case, 21 rows. And again, it's going to update the data table, which will take a little bit of time because it's cycling through potentially more cases than it needs to. And that's right. So we do now get some errors. So if I go to level 61 and select that, you'll see that, and this is struggling. Let me force it to recalculate. On level 61, we're getting, why are we getting an error? Again, this I don't think is recalculating properly because it's being a bit slow. Yes, okay, there we go. It's still not working properly because it's still suggesting it does stop somewhere. So why would it not return an error? Tell you what, let's clear out the data table. That will speed things up. And we'll go to number 61 right there. Now we see on 61, it doesn't ever stop. So what we need to do is say if we don't find it, then we want to take the last of these, so this -1 rows, and that's going to give us our answer. Let's go back to the example, which gives us BC30, and then let's set up our data table, and then we'll hopefully have to do this once, and then we'll remove it because the Lambda, although effective, is not particularly efficient. Okay, and let's go to the case and just check. And I don't think these have updated anyway. So let's just force it to recalculate and just double check those. And it turns out there was no issue at all. All that happened is on my answers, which I'd copied over from my previous work, because I'd done the same thing I'm about to do where I removed the data table, my answers weren't actually there. So it was correct, but at least we tidied things up. So let's just clear out that. Actually, no, let's not make the same mistake again. Let's copy those as values only, and then clear out our data table just so we're not slowing down with constant recalculations of that lambda. So there you go. Problems of trying to do a recording of this. Right. Now let's analyze topography. Which type of terrain is associated with the listed cell on the map? It was in the video that said actually level 5 is easier than level 4, which we have some guidance there. So what we need to do is we're going to just grab these and we're going to name the ranges. So we don't have to, because this comes up on more than one question. So we're going to say address, look up. This time we're looking at map terrain. We're going to, let's try this all in one go, see if it works with the array. Oh, I didn't actually end up selecting the array. Let's see if this will handle. So then we get the first letters. So then what we'll do is we'll look up those on the color and return the terrain, which should work as an array. Yep, thought so. Level 6, you're given a cell where lava pops, and now you have to analyze topography. According to the given table, lava is moving faster depending on the field. What would now be the next cell? For the double and triple movements, ignore the topography of the interim cells. If lava pops in the designated cell, what would now be the next cell? It changes movement direction. Right, that's a lot of words, but I think I basically got the understanding here. So we've got custom speed. So I'm going to use a multiplier. So normal is 1, none is 0, normal 0, double is 2, triple is 3, and we'll call that speed, and we'll just name that range. And now we should have what we need here. So we're going to start by finding the arrow. So we're going to address lookup in the map arrow this. We're then going to find the terrain. So we're going to address lookup in the map terrain. Oh, can't type map terrain this cell. And we'll get a letter and then we'll wrap that in an X lookup, and we will return, what are we looking at? We're looking up a color and returning, and this time we can actually return the speed straight away. So I think I can do this in one step. And so actually all we want to do is we want to say move on map. Our starting point is this, our arrow is this, and our speed is that. And that looks good to me. Let's just copy that down. Let's just point those to our answers, make sure we're all correct. Yes, we are. Okay, level 7 takes that same idea, but we're now cascading down multiple steps. So this time I'm going to build it as a table, which I've already set up. So how many turns are we likely to have to take? Well, the largest number of magma is 20. The slowest speed we can go is 1. So in theory, the maximum number of turns is going to be 20. So let's just have a sequence of 20 turns to make sure we're covering ourselves. Our starting point is going to be this one, and we're going to do similar steps to what we just did before. So our arrow is going to be the address lookup in the map of arrows, our starting point. Our speed is going to be the address looking up in the map of terrain, looking up this cell, and then we'll wrap that in an X lookup. So we look up on the color and return the speed. Does that sound right? BK70. No, that shouldn't be speed. So what have I done wrong there? Let's just undo what I did. We got H. So H should equal, let's just look up color for a moment, and speed. Oh, why speed no longer? Where's my speed gone? That's what speed is referring to. Yes, it is. Those are numbers. H hills is 2. So what is going on? Speed. Let's try speed times 1. Nope. Let's try using a different name. Let's see if I've done something. Control function F3. Oh, that went well. Let's just call this speed 2. Oh, this is some annoying debugging I didn't expect to have to do. Okay, so don't know why that went wrong. So let's X look up if anyone knows. If you know why I did wrong, then please put it in the comments. So we're looking up based on the color and returning speed 2. Okay, that's fine. Our magma starts at 6 And we're going to have to keep track of when we run out of magma and where we are when that happens. So our next cell is going to be move on map, starting in this cell. This is our arrow. This is our multiple. And for now, that should be okay, but we'll see in a moment that something else is going to happen. And I'm going to drag those down. And something's gone wrong here. Yes, our magma is not just dragging that down. So then our magma is going to be how much we had before minus how much we've used, which is actually just the speed. And again, if I just fill that down, we'll start hitting negative. So we don't want to have negative. So what we're going to say is we'll say it's the maximum of 0 and that. So we don't hit into 0. So we then get zeros. And then what we're going to do is what we find here is that in the example, we reach BJ73 and then we only have one left. So although this would normally, if we move 2 in this direction, we would get to BL71. We actually need to stop halfway. So what we need to say to this is that our speed or our number of multiples is the, let me think about this, the minimum, the lower of the speed, the magma that's left and the multiple, and that stops us at BK72. So we'll just drag that up and then fill it down to make sure we're at the correct place. And then what we're going to say is we're going to say X lookup 0. So when do we run out here, and return our cell here. And that's going to work for some, but not for all, because sometimes we will stop before we run out. So if we look at these errors, we go to 1, 2, 3. No, that's not calculating correctly. That's giving me BC, which is 1, 2, 2. So let me just force it to recalculate. So we can actually be dealing with the one. Oh, it's because because I got my other document open. It's running some stuff in the background there, which is why it's been a bit slow. So what we find is we basically, after the second step, we hit BG28, and that's water or river or something. So the speed is nothing. So we stop. So what we're going to say, if we have, what we'll say is, what's the final step? Well, if that happens, whatever we have down here will be the correct one. So if we take from here the last result, and then in our X lookup, we'll just say if we don't find it, then just take this as the final result. And that should give us our answers. And we'll go to level 7 just to double check. Oh, we've got a couple wrong. Let's just force that to recalculate just in case something is going wrong. And then otherwise, just let me check my work. Okay, I think I've spotted the error where I'm taking one from the other. It's actually the speed from the previous round, which should be what I'm taking. And if I go now to my workings, yep, that's all correct. Right, how are we doing on time? 17 minutes with a bit of explanation showing off the lambda as well. So yeah, well within time. So among all the possible directions, only one is not in level 1 answers. Which one is it? So let's just take our just take unique of these. And indeed, we see there are only 7. So let's find our arrows. Probably could do this visually, but just in case, and then let's just go exists these items. Which of these items exist in this list? And the false comes up on this top right or upright arrow. What is the cell where lava appears most frequently on levels 1 to 7? So the cell references are always in column G. So if we just say equals most least, let's go from G48 to G1000 just to be on the safe side, and we'll just take let's just take the single returns to the first row. Oh, we need, because we've got a cell which appears lots of times, so in that case let's go, let's just take the first 2 rows, and then we see it's AM47. How many cells that contain water are there in the map? So if we go to the map, we go to topography, we haven't actually got the water cells saying S for C, so I'm going to use OA robot to grab all the blue cells, and then I'm going to put an S in there, and then if I go back to here, I can say, right, let's take the sum of minus of where the map topography equals S, and add that to, add that to the same again. So the sum of the minus of MPT equals R for river, and that should close off to 421.3. On level 4, find all the game numbers where the lava flow ended into the sea. So we go to level 4, and let's reanimate our data table, which will be a little bit slow, but we can copy the values if we need to, just to speed things up. And I've actually got multiple files open, which is why that's a little bit slower. Let's just copy those as values openly. And then what we want to know is, let's address lookup these, sorry, not the map terrain on those. And we want to find the ones where it's C, so let's, or where it's S for C, so we'll filter these game numbers where, oh, it's, yeah, where it's C, not just, or is it river? No, I think it was just 4 when it ends in the C, and then we sum those to get 293. And now we get to the hardest question. We've got 10 minutes if we really need to, because we always aim to get this under half an hour. If you forget the topography issue and only follow the arrows on the map, considering an infinite amount of magma, what is the maximum distance lava has to travel to reach the sea? Now, one approach could be to try and use my arrows on map Lambda and find all the cells that have this, but I think that's going to be really super slow. So I think a better approach is to do this. We're going to make a copy of the map. Going to go, they call this dynamic programming or dynamic. Anyway, what we're going to do is we're going to point to a cell and we're going to say the following. So we're going to say if, let's say if the topography exclamation B2 equals S, then this is 0. Otherwise, we're going to create if statements. We're going to say, actually we should use ifs, and then we can just say, right, map exclamation B2 equals, and I'm going to use my arrow from text lambdas to sort this out. So if our arrow, let's start by going up. So we're saying if the equivalent cell in this map is pointing up, then we want to look at the cell above us because we're coming from that direction. We're flowing into that, so we're coming from that direction. So we will say B2 plus 1. And then we're just going to repeat this process in all 8 directions. So I'm going to just copy this and then copy one more time, and I will have my 8 different directions, and then I'm going to go through those. So if we're going up right, we need to point at C1. If we're going right, we need to point at C2. If we're going down right, we need to point at C3. If we're just going down, we need to point at B2. If we're going down left, we need to point at A3. Which that down should be B3, shouldn't it? And then if we're going left, we should be pointing at A2. And if we're going up left, we're pointing at A1. And that will give us a 0 here because we're in the C. But if we copy that, and if I go to the end, select the whole of the map, paste as formulas, and I will need to enable iterative calculations. So we will go Control-Shift-O for a robot, enable iterative calculations, and it's going to freak out for a second. But now we get some numbers, and basically what we're doing is we're going from the C, starting at 0, and we're just adding up based on the direction we go. And so if I now select all of this, and the maximum number, the highest we get is 57. And there we go. How are we doing for time? 23 minutes. Let's just quickly try this. Might fail statically, but let's see whether my Lambda is up to it. So let's go to if map of terrain doesn't equal S, it's not the C, then return the cell address of map terrain. Otherwise, return something that's going to force me to get an error. And then let's call this with a 3 to get all the cell addresses. I mean, we could probably eliminate those that are close to the sea, but we just don't know. There might be a cliff top that means there actually is kind of a route that goes right from one side of the island, because you could actually have it that, you know, this is flowing away from the sea and it goes all the way, cascades across the island. So we can't even make an assumption there. So what are we trying to do? We're trying to move through map of arrows. We're starting at this cell and we're going through the map of arrows, and that takes us to Okay, so we're on the C, I think there. That's why that's only giving us one. If we drag this down, we might start getting some more. Okay, you can already see just doing about 30 there. Yeah, this is going to take a long time because we've got 4,000. I just don't think it's going to be worth it. This needs to be, yeah, something else is going on. But basically what we want to do is we want to take the rows of this, will tell us how many steps there were. Is it rows? Oh, rows. And if I fill that down, again, you can see it starts to calculate there. Okay, what I'm going to do is I'm going to try dragging this down, and if it's taking a super long time, I'll pause and then keep an eye on how long it took. And we'll see if we get the same answer. So I'm going to double click on that, and it's going to start working through. And I'm going to pause the recording, and I will start a stopwatch to see how long this takes. Okay, we're back. Actually, that only took about 2.5 minutes. It took 2.5 minutes, but actually, if I highlight this column and select, you'll see that the maximum is also 57. So it was able to do that within the time we had. So yeah, not great for a competition. Obviously, the dynamic solution much better. But if on a smaller map, it might have been. This is quite fiddly. What I did here. On a smaller map, it might have been easier to do. And what I probably could have done is limited the number of steps. So if, for example, I go back to this and I change the, well, if I know, be interested if I try changing this to 58 as the maximum number of steps. I don't know how much quicker that will be. Oh no, now I've forced it to try and recalculate all of those sums. So I should have cancelled that before. So let's see if I can stop that. Yes, I can. Okay, yeah, let's not play around with that because we haven't got too much time. But yeah, really good case. Great to practice maps ahead of upcoming competitions. Really obviously reliant on lambdas to be quick and efficient through those. And great to finally do a dynamic program kind of case on that last map question and get it working. So yeah, great. Thanks for watching. Hope you found it helpful. As always, I find it helpful anyway. So even if no one's watching this, doesn't really matter. It's all good for me.